This is a technique that I teach for you to know the sign of the torque, okay? I will give you two examples. For this, you are going to need your pencil. Your pencil, your pen, okay? Now, from your pencil, you're going to hold it firmly from the eraser side, okay? Hold it like this, from the eraser. Now, I'm going to try applying a force like the one you see over here. Okay, so this force is being applied downward. So with your finger, try to move the pencil like that, downward. So what are you doing? What do you see? Where is the pencil moving? I'm going to draw two different lines, okay? Is the pencil moving like this? Like the red path, or is the pencil moving like the yellow path? What is the pattern that you see? Green or yellow?
Green.
Green. So when you push your pencil downward, this is the pattern that you get. Like that. Now, this, if you continue, if you project this rotation, in the end, you are saying you are following that trace, okay? So what happens when you have this kind of rotation? Is this clockwise or counterclockwise? Where is it going? Clockwise or counterclockwise?
Clockwise.
If it is clockwise, is it positive or is it negative?
Negative.
Clockwise is negative, okay? Clockwise is negative. It is the same convention that I gave you the day before yesterday, okay? So, with your pencil, you can tell, okay, the type of rotation that you have. If the rotation is clockwise, you will consider this torque to be negative. Now, I'm going to try another example. I'm going to change my force now. Bueno, ahí lo voy a dejar. Solamente voy a hacer otro. Now I will do another example like this. Now I'm going to apply a force number 2, okay? Again, you are going to hold your pencil from the eraser. The eraser is known as the hinge because that is the part that is not moving. You are just rotating in the opposite side of the pencil, the tip of the pencil, okay? So now you are applying a force 2. The force 2 goes upward. So hold your pencil and apply the force. What pattern do you see? Do you see green pattern or do you see red pattern?
Red. Red.
Okay, so because we see the red pattern, we're gonna focus on this shape that is going to be formed. This shape is nothing more than this. Do you understand this rotation? I mean, if you continue moving your finger upward, what is going to happen? The pencil will rotate, okay? The pencil will rotate. I don't want to do it with this because I think I'm going to break it or something. So how do you consider this rotation? The name of that rotation, the direction of that rotation is known as counterclockwise, or in Spanish, en contra de las manecillas del reloj. What happens when you have counterclockwise direction? Is it positive or is it negative?
Positive.
Positive.
So this rotation counterclockwise is going to be positive. Now, the example for torque, I'm going to do today an example of by using pencils, okay, or something related to pencils. Then I will use other kind of examples. But again, the pencil test is going to help you a lot to know if it's the torque positive or negative. Now, remember, so far, are we clear on the sign of the torque?
Yes.
Okay. Now, take a look. I have here two equations for torque. One that is force times distance, and the other is force times distance, or lever arm, times the sine of the angle. Sometimes the forces will be applied with an angle, and some other times they are not. So, let's see. I will do right now an example using a pencil, okay? Only for you to see the representation of this kind of exercise. Calculate the torque applied on a pencil when a force of 10 Newton is acting on Ok, este es el ejemplo que vamos a trabajar. Ok. Calculate the torque applied on a pencil. Ok, me falta información. The pencil is 18 centimeters long. Okay, so this is the first example. What do you need for your example? You need a sketch, okay? You need a sketch. So the first thing that we're gonna do is, we can do a sketch for this. Me, I'm gonna use the pencil from the examples before. Okay, so first what I'm gonna do is, I will prepare a sketch. Okay, what do I know about the pencil?
That is 18 centimeters.
Mm-hmm. It is 18 centimeters long.
And that has some force in the tip of the pencil.
That's right. So it measures 18 centimeters. And a force is applied on the pencil. I didn't specify the force. Okay. Where do you want the force to be applied? Downward or upward? Just tell me. I can do it both ways.
Upward, no upward.
Okay, upward is acting on the tip of the pencil. Because the force is acting upward, I will put my force right here. Now, what do I know about the force?
That is 10 Newton.
It is 10 Newton. So I'm going to write the information of the force, 10 Newton. Okay, remember the force can be used or can be replaced by the finger only for you to apply the force, okay? So keep this in mind. You can use both. So let's work on this. Okay, the upper finger is an upper force. It represents an upward force. And the downward finger represents a downward force. Okay, keep it like that. So that is the what you're going to do, okay? The force, the direction of the force tells you how to put their finger, okay? Now, what do you think we need to do after all the sketch and the signs of the forces? We need to write the givens. What are the givens that we have? I have, that's it.
The force.
I have given a force that is 10 Newton and it's going upward. How are we going to say, or how are we going to write the data about the size of the pencil? With what letter do we represent a distance, or in this case, lever arm for the torque formula?
Letter D.
Letter D. D, which is the lever arm, it is the distance, remember. Distance from the hinge, from the force to the hinge. What is the hinge in the problem? What is the hinge in the pencil? Is it the tip or is it the eraser?
The eraser.
Okay, in this case, remember it is the eraser. Okay, so it says distance from the force to the hinge. What is that distance?
18 centimeters.
18 centimeters long, okay? Now, what happens here? I need to do something. In what units do we usually write the distances? Is it in kilometers? Is it in yards? Is it feet? They are in meters. Remember, the main unit to talk about length is meter. So we need to convert from centimeters to meters. You can do the conversion with you. I don't know if you remember the conversion, that is that in 1 meter we have 100 centimeters. Okay, so this is going to be in the end how much? Eliminate centimeters with centimeters. It is
Meters.
0.18 meters. Okay, remember, every time you don't have the main unit, you have to do a conversion. Okay, now what do? We're going to do the solution process. Okay, what we do in the first place is we write a formula torque is equal to force times lever arm times the sine of the angle. Is the force applied at an angle or is straight upward? Guys, is the force applied at an angle or it is straight upward?
At an angle.
Actually, yes, it is applied at an angle. ¿Qué ángulo tenemos ahí? What is the angle here? ¿Qué
90
ángulo es?
degrees, a right angle.
90 degrees. And I know it might sound like a contradictory message because I say if there are no angles, you don't write the sign of the angle. But what happens when you have straight forces? What happens when you have straight forces? That you have an angle of 90 and the sign of 90 is going to be one. You have to load your microphone.
¿Cómo? No, entonces capaz.
Eli, you have to load your microphone. I already did it for you. Okay, so as I was saying, in this case, the force is at an angle of 90, but the sign of 90 is 1, okay? So when you have straight forces, you don't need to write the sign of the angle because it's always going to be 1. That's why I gave you 2 different formulas, okay? So you can skip this for now because we don't have an angle different than 90 going on over there. So we say torque equals the force, which is 10 Newton, times the distance, that is 0.18 meters. How much is this? This is 1.8, right?
Yes, miss.
Okay.
Yeah.
What are the units that you must write for torque? I gave it to you. The SI units that we must write for torque is Newton meter, because those are the units that you are multiplying. So this will be Newton meter. That's the unit. Now, torque is a vector quantity, which means that it requires direction. What is the direction that we are going to write? ¿Qué dirección del torque tenemos? Let's see. When you apply the force upward, what is the torque that we're going to have? Clockwise or counterclockwise?
Counterclockwise.
Vamos a ver. You can draw you can project the motion of the pencil. So when you move it upward, when you apply the force upward, it looks more like that, right? Now this is the same as having this. And if it is like that, positive or negative?
Positive.
Positive. Okay. So now, after you finish to calculate the torque, you're going to write the sign, the symbol. Sorry. Like that. Sorry. Well, you can write it like that or just plus 1.8. But I prefer you to include the rotation sign over there. That is counterclockwise. And that's it. That's how you calculate torque for a very simple very simple problem for torque. That's it. So far, for this exercise, do you have a doubt? For this exercise, do you have a doubt?
No.
No, miss.
Okay.